Hello there guys, and welcome back to another epic Inexorable Maths video. In this video we're looking at an interesting problem. This is a nested radical question. So what that means is, I'll show you, we're going to try and find the value of the square root of 1 plus 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 forever. So we're going to take the square root of all of this, like so. And these are all inside square roots, as you can see here. Just filling those square roots in right now. There you go. So it's like an infinite square root issue. That's why it's nested, because there's kind of an infinite number of these square roots, and we want to know what this is equal to. So what is that equal to? So this is the square root of 1 plus 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 forever. So it's like, well, you might look at this and think, I don't even know how to start. Like, it's so abstract, right? There's an infinite number of square roots in this. How are we supposed to find this? Does it even have a value? Turns out that actually it does, and it's quite cool. So this is how you do it. And this is how you do a lot of nested problems. So the radical part, just a radical is the square root symbol. So the square root symbol, this symbol, is not actually called the square root symbol. It's called the radical symbol or sign. So that's a radical right there. So it's a nested radical problem. You can think of it like that. Now, how do we actually do it? Well, as I say, this method works a lot of the time. If you have something like this is an infinite number of square roots. You can say that, well, first of all, let's just call it x. Yeah, let's just say that the whole thing is equal to x, and we're going to try and find the value of x. That seems helpful. Say that that's x. Or we can put x on the other side, maybe, to make it a bit easier. So we'll say x equals all of that, right? Makes sense so far. We want to know what x is. Now we have an equation. Well, we can also say that x is equal to, and then this is the leap, this is the important thing. What is this? This is the square root, just the bit that I've kind of put like in that sort of little bracket thing. Just that on its own is the square root of 1 plus 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 forever. And there's still an infinite number of terms inside just that bit. So actually, this is also equal to x, right? That bit there is also equal to x. So we can say that x, the thing that we're looking for, is equal to the square root of 1 plus, and then all of this, well, this is just x as well, so it's the square root of 1 plus x. And now, do you see how much this simplifies the problem? It's now not a hard equation to solve. So let's square both sides. Get x squared equals 1 plus x. And then we just rearrange this, so then we get x squared minus x minus 1 equals 0. Now, this is a quadratic equation. You can solve this quadratic equation using the quadratic formula if you would like to, or other methods. You can use completing the square, etc, etc, etc. You might recognize that this is actually going to be a very famous number, because there is this number called the golden ratio, which we give phi, the Greek letter there. The golden ratio satisfies the equation phi squared minus phi minus 1 equals 0. Phi satisfies that equation. The golden ratio satisfies that equation. The golden ratio is a number. Okay, it's about 1.6 something. It's a number. It satisfies that equation. So actually, we know, without even using the quadratic formula, if you're familiar with the golden ratio, we know that the solution to this is that x is equal to phi, the golden ratio. What is phi? Well, phi is 1 plus the square root of 5 divided by 2. Now, of course, you're going to get two answers for this because it's a quadratic equation. The negative version of this answer is clearly not valid. We squared both sides, so when you square both sides of an equation, sometimes you end up kind of creating answers that you don't need. But just use your intuition, because the square root of 5 is bigger than 1. So if you were to do, because technically it's 1 plus or minus the square root of 5 over 2. Don't worry about the golden ratio stuff. That's just using the quadratic formula. Don't worry if you don't know what the golden ratio is. that's the answer, right? 1 plus or minus root 5 over 2. If you use the quadratic formula minus b plus minus square root of b squared minus 4ac over 2a. If you use that, then it's fine. But 1 minus root 5 over 2 is a negative number. If we look at our original equation, this is clearly a positive number, right? There's no negatives in this question. So it's clearly a positive number. So we can get rid of the negative solution. And we can say that x is just equal to 1 plus the square root of 5 over 2 only. It's only equal to, because we can say that the quadratic formula gives us the negative answer as well. We only want 1 plus the square root of 5 over 2. The number 1 plus root 5 over 2 happens also to be the golden ratio. So the answer to this problem is actually 1 plus root 5 over 2, which means the square root of 1 plus the square root of 1 plus the square root of 1 plus, etc. is just 1 plus root 5 over 2. Which is also the golden ratio. So it's also equal to the golden ratio, which is really cool as well. Thank you guys so much for watching. I highly appreciate it. And I'll see you in the next video. Cheers.